So today we're talking about arc length and sector area of circles. So you probably remember this from geometry, you might not, it's okay. This does play an important part in when we're talking about the unit circle a little bit, but this is just something, good refresher, and honestly, it's really an easy topic to get once you see a few examples. So it's just finding the central angle. So when we're finding the central angle, we're going to look at where we have our degrees or our radians defined. So here, this 120 is our central angle, and I'm going to call that the CA. And then right here is where we have our central angle here, which is the 11 pi over 6. So I'm just going to write that down. The central angle is this, and our central angle is 11 pi over 6. So another thing we need to look for is our radius. Luckily, the radius is pretty easy to see because it's not going to have any type of degrees or pi or anything like that. That's just going to be this, the other number. So in this case, our radius, which we're going to call lowercase r, is 4 feet. And the pi over 6, pi over 6 is not the central angle. It's the central angle, that's not the radius. This 2 centimeters is our radius for this circle, which is here. So for this, we need to find the arc length and the sector area. I'm going to start with the first circle because it's got an important thing that we need to remember. If you remember in the Trig Handbook, to use our basic formulas, which we write them down here, so to find our arc length, which is S, so S is arc length, right here, it's just our radius times our central angle. But the catch is with the central angle, and it needs to be in radians. So that's not too bad with the second circle. All we gotta do is just multiply, and look at that, we're done. But for the first circle, we have degrees. So we need to transfer those degrees into radians before we can even start with our formula. There is a couple of formulas that if you look online that is just for degrees, in which it just has the converting the angle as a part of the formula. I just say just do the convert it to radians first, and then you can do it, because it makes it so much easier. And you don't have to worry about, oh, am I doing this right? The formula just gets really complicated. I prefer this. I think you guys will too. It makes sense. So I'm going to put the sector area. So our sector area, as always with any area, is just going to be a capital A. So our sector area equals our, whatever our center angle is, divided by 2, and r multiplied by r squared. For this, we're just like, remember with the pizza, right? You look at a pizza, pizzas have slices. That's what that is. It's just taking a slice of this circle and measuring the area of it. So if you really want to impress your friends, which I totally wouldn't do because it's kind of nerdy, but if you want to, that's fine. You could take their slice of pizza, take a protractor, measure out the degrees, and then convert it into radians, and then measure out the radius of the pizza, and then tell them how big of a slice they have, so then they can think it's cool. I think it's cool. If you did that to me, I'd think you were cool. But remember also with the central angle here, it needs to be in radians. Alright, so we're going to go ahead and go with the first circle. So, big thing. We have 120 degrees. So if you remember, when we're converting from degrees to radians, we take our angle and multiply it by pi over 180 degrees. So in this case, we have 120 here, 120 degrees times pi over 180 degrees. So I'm going to grab a different color to do our simplifying. Well, this degree and this degree here, they cancel out. So all we're left with is 120 pi over 180. Now, you can leave it like this. If you're going to have to do simplifying later, your numbers are going to be huge, and honestly, I wouldn't want to do that if I were you. So what I would do is start figuring out what goes in here. So 120 and 180 are divisible by 60. So I'm going to go ahead and just divide the numerator by 60 and the denominator by 60. And when you do that, what you're left with is 2 pi over 3. Easy enough. So if you don't see it, you can always just keep breaking it down and divide it by 2, divide it by 3, divide it by every number until you get to the simplified number. This one is just easy because it's 60 degrees. It's also one of our special angles we'll see later in the unit circle. So memorizing that angle measure might not be too much of a bad thing. Well, luckily, now we have our central angle in radians, so now we can go ahead and just plug into our formulas. So to find the arc length of this circle here, we take our radius, which is 4 feet, remember to keep your units, times 2 pi over 3. Now we got that dreaded fraction, and we're going to see a lot of fractions in this unit. We always will. All we need to do, set this to 4 feet over 1, and then do our multiplication. And what we're left with for the sector area is 8 pi, because 4 times 2 is 8. And I'm going to keep my units of feet. 1 times 3 is 3. And that will be our answer for arc length. Now, on to sector area. Now this one's where it's going to get a little bit funky, but it shouldn't be too bad. I'm going to write it down here. So area, so our sector area of this circle here is going to be 2 pi divided by 3 divided by 2. And what you need to do is always remember to put your units within the parentheses when you're taking the square. So I'm going to put this as 4 feet, the quantity of 4 feet squared. And now we just do our simplifying and we'll get our sector area. So the big thing is over here with this 2 pi divided by 3 divided by 2. So if you remember from a long time ago, keep change flip. So in this case, we keep the 2 pi over 3. We change the sign to multiplication, and we flip the over 2. So the over 2 is actually just 1/2. So if we flip it, we get 2 over 1. So we have 2 over 1. That's really bad too, but we're just going to go with it. And we can simplify this now, or we can simplify it later. I'm going to do it later. Let's take one step at a time. So the quantity 4 feet squared. So 2 pi times 2 is 4 pi. And 3 times 1 is just 3. And then we take our 4 feet, quantity 4 feet squared. Now we're on our last leg. So with this, like anything we square, all we need to do is we need to take the 4, well, we're just going to leave the 4 pi over 3. So 4 squared is 16, and feet squared is, guess what, feet squared. Not too bad. And then all we need to do, we can set this over 1 to simplify the rest. So 4 times 16 is 64 feet squared all over 3. And that is our sector area because we can't simplify anymore. Not too bad, right? Well, the next one's going to be even easier. Why? Well, we already have radians. The hardest thing is converting the degrees into radians. Once you do that, everything is simple. Everything that we're doing is just going to be plugging into a formula. So, the sector area of circle number 2. Well, or let's not do the sector area, let's do the arc length first. So the arc length of this. Arc length is represented by S. We take our radius, which is 2 centimeters. We take our central angle. Since it's already in radians, we're good. Which is going to be 11 pi over 6. Well, all we need to do is the multiplication, so set that over 1. 2 centimeters times 11 pi. Well, 11 times 2 is 22 pi centimeters. And you can leave the centimeters on the outside. It doesn't matter. And then we have 1 times 6, which is 6. Are we done with this, though? And the answer is no. Because we have a 22 in the numerator and we have a 6 in the denominator. These are both divisible by 2. So I'm going to go ahead and do my division, which is 2 pi centimeters divided by 2, which makes this 11 pi centimeters. And then 6 divided by 2, which is 3. And that is how we get our answer for that. And we're going to make it orange. Exactly, so I did that. Alright, so now we're going to move on to our sector area. So our sector area is equal to 11 pi over 6 divided by 2. Put our radius in parentheses, so we get 2 centimeters squared. So we do our same simplification as we did earlier. So area equals, keep our 11 pi over 6, change the sign to multiplication, and we change this to 2 over 1. And then we're just going to leave our 2 centimeter, quantity of 2 centimeters squared. We don't need to worry about that right now. So we simplify this and we get our area is 22 pi over 6. And let's go ahead and simplify now. So 2 squared is 4, and centimeters squared is centimeters squared. And now we set that over 1 and we can do our simplification. So you can set this over 1. I would start simplifying this. Right here is divisible by 2, this is divisible by 2, and this is everything is divisible by 2. So let's just go ahead and divide this by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And 22 divided by 2 is 11. So if we do our simplification, we get 11 times 2 is 22 pi centimeters squared, and then 3 times 1 is just 3. And that is our answer for that one. I notice you guys can't actually see it, so I'm going to go ahead and move it over so you actually can see the answers I just gave you. Again, when we're doing our sector area, we have 2 centimeters times 11 pi over 6. We just set the 2 centimeters over 1. We do 22 times pi, or we do 2 times 11, which is 22. And then we do pi centimeters divided by 6. Well, we had something that's divisible by 2, and we could simplify, so we divide it by 2 over the numerator by 2 and the denominator by 2, and we get 11 pi centimeters over 3. And then with the sector area, it's 11 pi over 6 divided by 2 times the quantity of 2 centimeters squared. So we do our cube change flip, 11 pi divided by 6 times 2 over 1 and 2 centimeters squared. You do your simplification. This time we just went ahead and simplified, so we didn't have to do anything funny, and made our time easier. And that's basically sector area and what we're doing. And if you remember looking at the Trig Handbook recently, we talked about these two subjects. They're important. They're not going to be the one things that we're going to be focusing on in Trig, but it's something that is very useful. And again, if you like the cheesy jokes, but if you like the cheesy jokes, you can take the sector area and find the area of your pizza up here. Anyways, see you in the